These notes are for Algebra 3, Unit 1, Section 1.2, Linear Equations and Rational Equations. So what you have to understand is equations are expressions that have an equal sign. So we've already went over expressions. Now we're just going to add an equal sign. So our goal is going to be a little bit different. We're looking to solve equations. In solving an equation, we're trying to find all the values for the variable that make the equation true. The words that can change, you could say solutions, you're looking for zeros, root, solution set, all those words mean the same thing. And it's important that you check your solutions to guarantee accuracy and also verify that it's not an extraneous solution. An extraneous solution means you did the math correct, your number comes out right, but when you plug it back into the equation, it does not work. So I have a few different examples here. My first example is very simple. 3x plus 7 is equal to 12. And you may have been taught different ways. I'm just going to go through the way that I tend to think of these problems. I write the equation down again, and I'm going to subtract 7 from both sides, which I get 3x equals 5. Then I want to isolate the x, so I divide by 3, and I get x is equal to 5/3. And then one of the ways you can check this is I'm going to store a value. So I'm going to get a fraction. I hit alpha, y equals, I got a fraction. 5 is in the numerator, 3 is in the denominator, and I'm going to come over and I'm going to hit the store button. The store button is down at the bottom, right below the on. And I'm going to store it for x, and I'm going to hit enter. Then I look back at my equation, 3x plus 7. So I type in 3x plus 7, and if it did it right, and when I hit enter, it should equal 12. Okay, I did it right, so I'm good. So that's one way to check it. My next example is a little bit more complicated, and I try to follow examples like what you have in the textbook that you'll be practicing. I have x minus, and then parentheses, 3x plus 1 plus 5 equals 4. I did this one on purpose because of the minus in front of the parentheses. I want to make sure you understand you have to distribute that minus sign, which really is you're multiplying everything by -1. So x minus 3x minus 1 plus 5 equals 4. Then I just start cleaning up. I combine x and -3x to get -2x. I combine a -1 and a 5 to get 4, and it equals 4. I want to isolate the x value, so I'm first going to subtract 4 from both sides. And I get -2x equals 0. I divide by -2, and I get x equals 0. And I've chosen this problem on purpose because sometimes students think, oh no, I got 0, it's wrong. There's nothing wrong with that. It actually worked. So you could check it, you plug the 0 back in for x, this is the long way to check it. And you do the math, and I have a question mark over the equal sign. I want to see if the left side is equal to 4, and you could put it in the calculator like I did before. And that one works. My next example is now a rational expression. I have x over 4 plus 3x over 2 equals 7 over 8. So there are two different ways to do this. I'll show you one way with this problem and a different way with the next problem. Since I have fractions, I have to get a common denominator. So I look on the left-hand side, and my common denominator between a 4 and a 2 is going to be 4. So I have to multiply the second fraction by 2 over 2. I'm going to leave the second side alone. So the left side, once I multiply by 2, I get x over 4 stays the same, plus 6x over 4 equals 7 over 8. Now I can combine the two fractions on the left to make one fraction. So x plus 6x equals 7x. So I have 7x over 4 equals 7 over 8. At this point, I cross multiply. Cross multiplying means I'm going to bring the 8 up and multiply by the 7x, go across the equal sign. This 4 is going to come up and multiply by the 7. So I have 7x multiplied by 8 equals 4 multiplied by 7. So I get 56x equals 28. Divide by 56, and then I reduce my fraction. And then I would check it. You don't have to show me that you've checked your work, but I do expect that you've checked your work. And the next example, this one I need a least common denominator. And I'm going to do a least common denominator across the whole thing. And this is just another way of doing this. And you could choose either way that you like, whichever way you're more comfortable with. So I have an x, a 3x, and this is just 1 by itself. So this is saying 1 over 1. So my least common denominator is going to be 3x. I have to multiply the first fraction by 3. The second fraction, I don't need to multiply anything. And on the other side of the equal sign, I have to multiply by 3x. Then I go ahead and multiply. I get to 18 over 3x minus 2 over 3x equals 3x over 3x. The process mathematically is I can multiply both sides by 3x over 1 here in green and here in green. When I do that, the 3x in the numerator is going to cancel out with the denominator on both sides. So I get 18 minus 2 equals 3x. Another way to look at it is once you have the same denominator all across everything, you don't need it anymore, and you just use the numerators. So once I have 16 equals 3x, I divide by 3, and I get x is equal to 16/3. Now this is where the excluded value comes back in. If I look back up here at where I started, I know that x cannot equal 0. In the example up here, that was okay. There was no fractions. Here, it can equal 0. If it becomes 0 when I work out my problem and I've done all my work correctly, it's an extraneous solution. But in this case, x equals 16/3 works. Now the problem's going to get a little bit more complicated, but the same idea still exists. So this example, I have this fraction 5 over x minus 2 plus 3 over x minus 1 equals 4 over x minus 2, x plus 1. So my least common denominator for everything is x minus 2 and x plus 1. And I've written that here. So when I create my fractions, I have to multiply the first term by x plus 1 over x plus 1, my second term by x minus 2 over x minus 2, and on the other side of the equal sign, I don't have to do any work. So now I skip a step. I know I have to multiply 5 by x plus 1. It's going to give me that denominator. I have to multiply 3 times x minus 2, and that's the same denominator in both cases, so I'm just going to write that once. Equals 4 over that denominator. So just like in the previous problem, I'm going to multiply both sides by the denominator. So now I don't need the denominator anymore, and it becomes a much more comfortable problem to work. Distribute to 5, I have 5x plus 5. Distribute to 3, I have 3x minus 6 equals 4. I'm going to combine like terms. 8x minus 1 equals 4. Add 1 to both sides, I get 8x equals 5. Divide by 8, I get x equals 5/8. And I'm going to go ahead and check my extraneous solutions here. X cannot equal 2 and negative 1, so this one works. And I would double check it. And I did double check this problem. The last example I have, this one's not factored, so I'm going to have to do some factoring. This 8 over x squared minus x minus 6. I factor the denominator. Just bring down the other terms from the right-hand side. So then my least common denominator is going to be x minus 3 and x plus 2. It's always nice when it turns out that simple. It could be a lot more complicated, but this one is fairly simple. My left-hand side, I don't need to do anything to that fraction. My right-hand side, I do have to change the x plus 2, and I just realized a mistake. I wanted to do this in pink. This is one of my erasable pens. I love it. I need to multiply this by x minus 3 over x minus 3. My numerator, 8 over this. 5 times x plus 2 is from here, plus 2 times x minus 3 is here. My denominator comes along, but the next step, I don't write the denominator. I just have 8. I distribute the 5 into the x plus 2. I distribute the 2 into the x minus 3. I'm combining like terms on the right-hand side, so I have 7x plus 4. Subtract 4 from both sides, I get 4 equals 7x. Divide by 7, I get x equals 4/7. Once again, look at my excluded values, make sure that this number is not extraneous. It's not, it's fine, and I check my work, and it works out fine.